Greetings and welcome to my second episode of the Earth episodes. In this episode, I look into some discoveries that I tried to check into some of the other possibilities, but, I foresaw the chance of so many cool things coming out of this, and I'm guessing that you're like me and that you're going to see the same cool possibilities, so, okay. So I begin with this major problem on Earth, the endless amounts of radiation, waste, and illegal dump sites, and, what can we do with them? It seems like a likely solution, radiation-eating bacteria. Radiation-eating bacteria could make a nuclear waste site safer. So, this data comes from several sources, from Russia, the UK, Scotland. Apparently every country has found the same thing out, which usually seems to happen. This discovery, this awesome thing, is all about a little teeny microbe. You see, these little microbes use radionuclides, such as uranium or neptunium, in place of oxygen. Studies have found that in doing so, they convert the radionuclides from soluble to insoluble and stymie radionuclides from motion. So, taking that discovery, the UK will take 4.5 million cubic meters of nuclear waste, that's enough to fill Wembley Stadium about 4 times over. That's from ponds and silos all at the surface level in Sellafield, Cumbria. The plan is to dispose of this highly active waste in repositories both underground and enclosed in cement. Now, the physical and chemical properties expected to stop this radioactive material from escaping for thousands of years. However, not biological. See, originally it was thought that the cement, which has a pH level around, it's similar to bleach, would be alkaline for microbes to survive. Surprise! They're fine. Actually, they're more than fine. They grow. These radiation levels that are found at dump sites pose no problem for the bacteria. It actually stimulates their growth. Now, the nuclear waste can contain cellulose, which breaks down to form, isacaronic ISA. Under alkaline conditions, ISA combines a soluble complex of uranium that then leaks out whatever container might be. Enter supermicrobe. The bacteria seems to use the IPA as a carbon source and so degrades it and then keeps the radionuclides in a solid form, which means they stay in place. But it doesn't stop there. Hydrogen can be produced by the reactions and causing a buildup and pressure cause it to explode or crack. Microbes to the rescue again. Microbes use the hydrogen and usually are able to keep the levels down. And then they fill in the cracks also. Now, I'm just spitballing here, but you know what I'm thinking of, right? Maybe they could use these in space. Maybe up front we could have the space radiation, it's all captured, and then the microbes are in here and they all eat it as we continue to plow through. I don't know, or they could reverse engineer something from the microbes, maybe accomplish what we need. From what I've been able to find out, back in 2011, NASA was thinking just that. Let me take you back to a young Earth. Young Earth lacked an ozone layer to shed enter microbes. Microbes flourish through adaptation. Now, are they some kind of extremophile? Does space, no gravity, no oxygen, other harsh conditions of space offer them a space vacation where they could be our new astronauts, micronauts, if you will? There's one common bacterium called Bacillus subtilis, which holds the record for space survival at 6 years, having spent time on NASA's long-duration exposure facility spacecraft. Say that 5 times fast. Anyway. The ordinary microbe has proven itself to be capable of evolving a resistance to UV radiation up to 3 times higher than that of the original ancestor, our non-exposed group. After 700 generations lived and died in the Earth-based lab experiment. Keeping up with the master theme, which this week would seem to be microbes, here's something. A Martian microbe could be eating carbon monoxide from the atmosphere. There are scientists that believe Martian microbes flourish beneath the red planet's ice-cemented polar caps and the briny puddles of the briny salty water. So, question, what does microbe eat? Well, one biologist at Louisiana State University thinks the answer might just be atmospheric gas, carbon monoxide. This would mean that it has live microbes on Mars, which means that it could sustain life. Not our life, at least not right now. You see, if you want to be Earth-like, then you need three things: nutrients, water, energy. Now Mars has lots of carbon dioxide, nutrients, nitrates, nitrogen, water, well, briny water. We've all discussed this about the briny sort that can be found, as well as that's frozen at its pole areas and in the soil. So, energy. Well, science have discounted the idea that energy could just be pulled from the atmosphere. You see, it's thin and dominated by carbon dioxide. Carbon dioxide is not a viable energy source. A very small portion of Mars' atmosphere is carbon monoxide, which is created as sunlight breaks an oxygen atom off of the carbon dioxide. Now, apparently these microbes that are living beneath the subsurface are still able to get enough of the carbon monoxide. So NASA was evaluating, among other possible landers, the icebreaker life, which would have been sent to Mars in 2021. But unfortunately, that mission lost out to Psyche and Lucy missions. Anyway, life is really interesting in all forms, microbes being one of them, and one that perhaps we haven't studied enough. I mean, think about it. If we could have one help us with climate change, to eat the carbon monoxide and carbon dioxide, or to work at it somehow, there's bound to be a way. I'm just thinking, spitballing ideas here on how science is going to come to our rescue. Partly. We all have to be secure in what we are doing as well. Now, I do know that maybe all the ways we try and find, we need to find initial ones that work. I want to bring you up to speed on something that I read about recently that worried me. Apparently, Scott Pruitt wants to change how science is used for the EPA regulations. Administrator Scott Pruitt, he said he wants to change the agency to rely only on studies that are fully transparent. He said, and I quote, "The era of secret science at the EPA is coming to an end. The ability to test, authenticate, and reproduce scientific findings is vital for the integrity of rulemaking process. Americans deserve to assess the legitimacy of the science underpinning EPA decisions that may impact their lives." I was unsure at first whether to cheer or to cry, and somehow I feel sure that cry would be the correct move. See, the secret science may be the most ambitious because of its potential scope. Limit the science that can be used as legal justification behind regulations, and you limit the regulations that can be approved. Now, in announcing the proposed rule, the EPA said that the change would also address the replication crisis, where a significant proportion of published research would not be deemed viable because it can't be reproduced. Now, before you think that's good, no, it's not. What that would mean is long-term studies, for example, that followed the health of children or poor women, or these things that take decades, could not be used in the EPA rule because replicating that research would be prohibitively expensive and cost lives by wasting valuable time. Hence, the EPA wouldn't be made over that because it wasn't repeatable science. Much of the health science research is done in this sort of a manner. So, that's a minor problem there, huh? Oddly, Scott Pruitt has adopted a red team, blue team model designed to challenge climate change assumptions that global warming is occurring and humans are the primary cause. This is a view that is endorsed by the vast majority of scientists and by a massive federal report which the White House issued earlier this month. Pruitt's push echoes that legislation and congressional and conservatives have been pushing for years. The Honest and Open new EPA Science Treatment Act of 2017, or HONEST Act as billed by its supporters, is a good government effort to make the research behind the federal government regulations transparent and defensible. One of its sponsors was Oklahoma Republican James Burtenstein, a climate change skeptic who was installed Monday as NASA's new administrator. In other words, NASA mission faces setback. That's the one that's aiming to protect the 2020 mission. NASA was testing the heat shields earlier this month when it developed a crack, and while undergoing the stress test, the crack appeared around the entire circumference. The heat shield, which is a critical part of NASA's next $2 billion rover, the mission to Mars, The shield is designed to protect the rover, so as it enters in, the shield will protect it as it goes through the atmosphere. But they were trying it on forces that were 20% greater than they expected, and, that's logical. So the crack forced the NASA engineers, they're going to have to build a new shield for the mission. Now, hopefully that will mess up when they're planning on sending it, because, it's supposed to demonstrate the steps needed for the next future Mars mission, so we'll receive samples that come back. So the heat shield is that curved structure. So as I've mentioned, it just stays underneath. Now it's a lightweight item. It doesn't weigh very much, but all that heat that they go through, if they go through on this side, they're fried. Temperatures of nearly 400 degrees Fahrenheit as the spacecraft comes screaming into the Mars atmosphere. First, the engineers need to work out why the crack occurred. Does it need a change to design? Was it a faulty aspect? There's a whole bunch of things that you need to, decision links you need to go through. You can't just, okay, we'll just put a new one and try the test again. So, anyway, let's change gears here. I wanted to show you the test launch from SpaceX and thought first we should find out a bit about tests. So, I'm going to show you a little test video here, and then it'll be great because we're going to space.
TESS, the Transiting Exoplanet Survey Satellite, is NASA's newest exoplanet mission. It's being led out of MIT, and it's going to find thousands of new planets orbiting bright nearby stars. And it's going to build upon the legacy of the Kepler mission, only it's going to focus on nearby bright stars that are sprinkled across the whole sky, and it's going to help us answer a really important question, and that is, which of our near-stellar neighbors has planets?
During its 2-year survey, TESS will look for signs of planets, ranging from Earth-size to giants larger than Jupiter. TESS will search for these new worlds, or exoplanets, using transits, the same method as the Kepler mission. As a planet passes in front of its star, it blocks some of the light, causing a slight drop in brightness. TESS can detect those subtle dips and even use them to determine some basic features of the planets, such as their size and orbit. Each of TESS's cameras has a 16.8 megapixel sensor covering a 24-degree square, large enough to contain an entire constellation.
And we'll see you next time on Space Time Continues. Thank you.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Mission liftoff.
Ground operators proceed to section 575. Flight report to procedure 3070 post-launch flight operations.